Hi, this is Team Epi팹봇, and we'll be presenting the Cyclone Air Purifier empowered by Tesla Turbomachinery and Electrostatic Precipitation project today. This photo has been taken on the same place at the Namsan Mountain. And obviously, if I ask you what difference do you see in this photo, you could say that it's the color, right? The dramatic difference in the atmosphere quality is dictated by air pollution. I guess everyone's familiar with this device, no? It's the air purifier. Especially here in Korea, the fine dust issue, which is being treated as a disaster even, caused a lot of households to buy this device for health issues. There are a lot of methods in air purifying, but the state-of-art technology that's being chosen in the field today is simply using filters for purification. As you can see in the figure on the left, air flows through multi-layered filters where relatively large aerosols are captured. The most popular filter that's being used today is called the HEPA filters, and this captures about 99% of fine particles that is small as 3 micrometers. Simply put, it's a very powerful filter. Then what's the big deal about it? What's the problem? Massive downside is that the HEPA filters, or any other standard air filters, are not recyclable, adding tons of waste into the already crowded landfills. Note that this is a serious problem here, especially in Korea, because there are limited places to utilize. And of course, this was a well-known issue, and lots of efforts have been made to replace the normal filters. As you can see here, plants, water, or electric charge was proposed as a replacement of the normal air filters. All of these developments are great replacements, great alternatives, but our team was intrigued by a more special type of air purifying method, the cyclone separator. As you can see here, these separators are mainly used in large-scale industrial applications. And the methodology that lies beneath this system is that blowers provide sufficient amount of airflow into the cyclone cleaning system where cyclone is generated as it follows the structure and the heavier molecules are dropped to the bottom. Because blowers are used as external power source, the entire cleaning system has to be bulk. So if the system were to be made into a much more compact system, power source has to be internal, and centrifugal compressor can be an option to this to be placed on top. Centrifugal compressor is a great option because it's proven technology, but because it uses impellers, when it's placed in dust concentrated regions, it can damage the impellers. And also, the question arose about the weight of the system. Thus, the team went a step forward and found a possible replacement of this traditional device, which is the Tesla turbomachinery. This utilizes boundary layer effects. The photo you see on the left is the original design by Tesla himself. If you look at a single disk here, if a flow passes by, the viscous force generated by the fluid and the solid surface generates torque that spins the disk. This viscous power transmitting effect is caused in the boundary layer. And if disks are multi-layered, this viscous effect could be maximized. As you can see here, there is velocity loss in terms of flow near the surface, which is translated into viscous force applied. If the distance between the disks are reduced, the free flow region is reduced, causing only boundary layers to exist within the gap. This means that most of the flow is translated into viscous force within the boundary layer. Simply put, Tesla turbomachinery is basically a boundary layer turbomachine. And as any other turbomachineries, the original design Tesla turbine can work as a compressor if torque is given instead. So the team designed a compact air purifier system with Tesla compressor that holds 28 discs inside. It is rotated by a hand-like holder instead of normal shaft so that the exit path of the cyclone structure can be made. Then ANSYS fluent study was done on the design, giving laminar flow condition for simplicity and 10 meter per sec as mass inlet. It can be seen that the cyclone is formed inside the bottom structure and exiting out. And then the actual outer shell was made using acryl for the top, Tesla compressor holder for visibility, and 3D printers for the cyclone generation structure because it was kind of expensive to make it from acryl. For this semester, the first step was done, and there are a lot more to do. The upcoming summer semester, Tesla compressor will be attached on top and measured. Additionally, electrostatic precipitation unit will be added at the bottoming part for extra capturing boosting.